In last video, we have explained the construction and working of a DC motor. DC motor simply means a motor which runs through a DC supply. When a DC voltage is given to its input terminals, the voltage pushes electric current to flow through the motor windings, and hence the windings create their own magnetic fields. Due to interaction of these magnetic fields, an electromagnetic torque acts on the rotor and the rotor rotates. This way, the given electrical energy gets converted into mechanical energy. In previous video, it is shown that static magnetic field is produced by giving direct current to the field windings. Armature also takes direct current to produce electromagnetic torque. Two different sources can be used to energize both the windings. It is called separate excitation. Or we can use a single source to feed both of them. This means self-excitation. Therefore, a DC motor can be of two types, separate excited or self-excited. A separate excited DC motor requires two different sources for its operation and they cannot be available everywhere. That's why this type is rarely used. Self-excited DC motor is used mostly because it requires a single source to run. Armature and field winding together can be connected to a single DC source in three ways. Number 1, in parallel or shunt. Number 2, in series. And number 3, in compound. Let's understand these three types one by one. Parallel or shunt DC motor. When armature and field winding are connected in parallel, then it is called shunt DC motor. Due to the same voltage applies to armature and field winding, the field winding must have higher resistance than armature. Otherwise, maximum current will flow through field winding and armature will produce less torque. For higher resistance, field winding must have large number of turn of thin wire. After all, the work of field winding is to produce static magnetic field whose strength is proportional to product of number of turn and the magnitude of current. If we use thin wire to reduce current, we must have to use large number of turn. Shunt motor have a special characteristic. It has a flat speed torque characteristic. That means it is capable to maintain constant speed from lower to higher value of load torque. Therefore, its speed regulation is very good. Number 2, series motor. When armature and field winding are connected in series, then it is called a DC series motor. Due to the same current passes through armature and field winding, the field winding must have lower resistance. Otherwise, current through armature will decrease and it results in again lower value of torque. To have lower value of resistance of field winding must contain thick wire and lesser number of turns. DC series motor also have a special property. Its starting torque is extremely high. That's why it is best suited for traction application, whereas its output torque decreases considerably with the increase in speed. Number 3, compound motor. Good speed regulation property of DC shunt motor and high starting torque property of DC series motor can be achieved in a single motor if it is of compound wound type. For this type, field winding divided into two parts. One part is connected in shunt and another part in series. As discussed before, the shunt winding must have thin wire with large number of turns and series winding must have thick wire with few number of turns. This type of motor is best suited for rolling mills and load which require large momentary torque. So this is about types of DC motors. In next video, we will discuss about speed control of DC motors. If yes, please like and share it. Dear friends, if you haven't subscribed our channel yet, please subscribe and also press the bell icon. Then only you will get notification of our upcoming videos. Thank you.